Good morning, all of you. My topic is Valence VSEPR Theory. VSEPR Theory full form: Valence shell electron pair repulsion theory. This theory was developed by Gillespie and Nernholm in 1957. This theory is very useful to predict the shape or geometry of covalent compounds. Gillespie has proposed the following rules to explain the shapes of molecules or ions. Rule number 1. The shape of covalent molecules or ion depend upon the number of bond pairs and lone pair present around the central metal. If the central atom of a molecule has no any lone pair, the shape of the molecule will be regular. The geometry of the molecule depend upon the number of bond pair as shown in the table. When the number of bond pair is 2, the geometry will be linear and the bond angle will be 180 degree. As for example, BeCl2 and MgCl2. The shape will be like this. And when the number of bond pair will be 3, the geometry will be trigonal planar and the bond angle will be 120 degree. As for example, BF3, BCl2. The shape will be trigonal planar, like will be this. Now, when the number of bond pair will be 4, the geometry will be tetrahedral and the bond angle will be 109 degree 28 seconds. The geometry will be like this, tetrahedral, and the example of tetrahedral geometry is CH4 SnCl4. When the number of bond pair will be 5, the geometry will be trigonal bipyramidal. The bond angle will be 90 degree and 180 degree. The shape will be like this, and the example of this geometry will be PCl5 SbCl5. And when the number of bond pair will be 6, the geometry will be octahedral and the bond angle will be 90 degree. And the geometry will be like this. And the example of this SF6 SiF6 7 2. And when the number if the central atom of a molecule is surrounded by the bond pair only, and hence there are no any lone pair in valence chain, then the molecule will has a regular geometry like this. Hence the geometry of the molecule is not distorted. But if the central atom of a molecule contains lone pair with the bond pair, the geometry of the molecule is distorted due to repulsion between lone pair, bond pair, then the geometry will be irregular. And also there is limitations of this VSEPR theory, that this theory does not explain the structure of molecule having polar bonds. This theory does not explain the geometry structure of molecule having polar bonds. The second is this theory does not explain the structure of molecule having extensive delocalized pi electron. This theory does not explain the shape of certain molecules which have an inert pair of electron, for example AX6E. VSEPR theory fails to explain the shape of certain transition metal compounds. This theory does not make any distinction between electron present in sp-df orbitals of the same shell. This theory fails to predict the exact angle in molecules like NH3 and H2 molecule which has distorted geometry. The VSEPR theory also fails to explain the difference in bond angles in a given series of bond angle like NH3, PH3, SH3 and SBH3, in which the central atom is different but is attached with two similar atoms. Thank you. Have a nice day.